Hello everyone. My name is Anusha. I work as a senior product manager in observability and manageability team. Today I'm going to present how to become a super DBA with new database performance tuning features. Along with me, I have my team member Bjorn, who would be presenting other features we have in EMCC. Agenda for today's session is as follows. Bjorn would be talking about workload analysis, and I will speak about the rest. All the features presented today are a part of Enterprise Manager Cloud Control 13.5, which are released in recent past. As a DBA, we often get stuck with performance issues. Here we are to navigate through such issues with today's session. If you guys have any questions, please drop them in the chat. I will also be sending the resources related to these features. Bjorn would be explaining workload analysis.
One of the challenges with performance regression is that it's rather difficult to identify the real performance regression and pinpoint the root cause. Around 90% of performance problems are caused by changed SQL performance, but on which statement? A scenario: it's Monday morning and I'm back at the office and the phone starts to ring. Users complain about bad performance, response time has increased. My first action is to take a look at the database performance homepage, and it's rather obvious that there is something wrong. Did we have any change over the weekend? No application change and no known database change. So what is the problem? And a regression on SQL statements? And if so, how can I identify these statements? And last but not least, how can I redeem the problem as soon as possible? Do you recognize this type of problem? So how can we identify a problem as fast as possible and fix it? Workload Analysis can help us with this because here we have the ability to compare SQL executions between two different time periods. If we expect the workload to be the same, then we want to find out what's different. Workload Analysis have the ability to provide you with a detailed report where we quantify the total change in the workload and also impact on unique SQL statements with details of regression such as plan changes. Workload Analysis will help us with an automated analysis of changed SQL statements during a certain time period by comparing execution statistic and execution plans from a reference time period. So how do we find a reference time period? You could collect reference workload when the database had minimal problems according to our knowledge, like the batch finished in certain times or online users had good performance. But it could also be that we strive to find this day when everything works as smooth as an oiled engine. In the first case, we can do the comparison against a fixed baseline. Here we know that this is good, and when something is changed, then we can see what's changed. In the second case, we compare against a rolling baseline to identify both improvements and regression. When we have improvements, then our goal is to maintain the improved performance. As soon as it starts to regress, then we can identify why, and if the why is a plan change, then we can use SQL plan baselines to stabilize the plan. Even if there are no plan changes, then we can use SQL Tuning Advisor that would provide advices such as SQL profiles or new index among other advices. So what about my bad Monday? First of all, I need some type of reference, so I have SQL tuning sets from a good period. In that case, what I can do is to schedule a one-time analysis. I capture a new SQL tuning set and then I can perform a comparison. Or I expected this to happen sooner or later, so I have a scheduled job constantly comparing the workload either using a fixed or a rolling baseline. So instead of starting to analyze AWR compare period reports and similar, I can start to see if I have any SQL statements with change performance. The report that is creating as part of the scheduled job provides us with detailed information. First of all, it has a summary section providing us with overall impact. So here we can see if the database has more or less to do. By default, there have been 3 reports generated: elapsed time, buffer gets, and CPU. So now we can see what's increased, but also why. Any changes on common SQL statements, which are statements executed in both time periods. For common SQL statement, it is possible to see details on the amount of SQL statements in different categories: regressed, improved, or unchanged. There is also a section for missing SQL statement. This shows statements that was not found in the SQL tuning set for the new period. And then we have a section for new SQL statements. Regression and new SQL statements contribute to the performance degradation, and this is where we should focus our efforts. Regression can be caused by different factors, plan changes, but also increased data volumes. New SQL could be that there are some new activity introduced or that some activity appears as top SQL. As an example, the sales manager always generates a certain report on Monday morning, scheduling at a specific time. Due to certain circumstances, it took longer time, so it continued to run after online users started to use the database. The report is a rather interactive report. If we in the breakdown tiles find something of interest, such as regressed SQL statements or new SQL statements, then by a click on the graph, we filter the bottom tile to only show SQL statements of interest. Here we can filter on improved SQL, regressed SQL, new SQL, missing SQL, and SQL with plan changes.
ADDM Spotlight. It's a new developed feature which is introduced in EMCC 13.5 RU13. Before we move on with ADDM Spotlight, let's first understand ADDM, which stands for Automatic Database Diagnostic Monitor, which is one of the powerful features of self-managing Oracle database. ADDM has long helped DBAs diagnose and solve serious performance issues since its introduction in Oracle 10G. ADDM findings and recommendations encapsulate hundreds of person-years of Oracle performance expertise, and these findings and recommendations are made hourly over AWR snapshots. They are time-bound and thus inherently tactical in nature. What's the challenge people face? Implementing ADDM recommendations may involve some risk or significant cost and effort. It would have put DBAs in a position to contemplate between the cost versus benefit of the impact of any recommendations suggested by ADDM. So we have ADDM Spotlight, which aggregates findings and recommendations over days or weeks to identify overall benefit and frequency of occurrence. This enables DBAs to holistically assess the impact and benefit of findings and recommendations over the entire set of workloads serviced by the database. What's so amazing about this feature? It gives us confidence in implementing changes. It helps people with a little expertise to have an expert advice and level up to strategy with the data we get from ADDM Spotlight. Thus, ADDM Spotlight uplevels tactical problem-solving advice into strategic insights for optimizing database system performance. It's available in EMCC and OCI Operations Insights. Today, I'm going to cover features such as event annotation and other tabs that we have. That's findings, recommendations, and database parameters. As you log into Oracle Enterprise Manager Cloud Control and choose a database, you'll find ADDM Spotlight under Performance menu. The other way you can access it is from Recommendations section in DB homepage. Let's understand Summary Timeline, which is with stacked bars, which gives a quick glimpse of what all happened on the database in a specific time window. This is color-coded, which is similar to weight class color branding. Events Annotation. This is an enhancement to the feature which is released in RU16. It is called Events Annotation. As the name suggests, it annotates the event that occurred in the database. Events like DB restart and configuration changes. As in when DB restarted within specified time window, an availability icon is visible. As you hover over it, you can see the exact time of the recent DB restart. As for the configuration changes, it gives before and after values of modified parameters. ADDM Spotlight is broadly divided into 3 categories, which stand out to be the highlight, that is, finding, recommendations, and database parameters, which we deep dive as we move forward. This feature is a part of diagnostic pack. Findings. Let's first begin with findings section. These findings are taken by summarizing the data from ADDM task execution over a time period. The analysis results identify potential performance bottlenecks during that time range. While hourly reports are useful, there may be unusual one-time activity during this time range. However, viewing these results over longer or business meaningful time ranges may provide a better understanding of overall DB performance. Emphasizing persistent and impactful issues shown in frequency and overall impact column. These findings can be filtered based on categories such as CPU, top SQL, IO, and application. Recommendations. ADDM Spotlights will display recommendations list against objects on the recommendation tab. One can access the information using radio button for database parameters, SQL, and schema objects. Finding tab display the impact of the finding, whereas recommendation talks about the benefit of it. Recommendations are composed of actions and rationales. One can apply the actions of a recommendation to gain the estimated benefit. The rationales explain why these actions were recommended and provide additional information about suggested recommendation. Any issues related to SQL are prominent everywhere. So this comes handy if there is a newbie and want to tap into understanding the performance of SQL query. Each SQL recommendation may display options as view SQL text or run SQL tuning advisor. Database parameters. Database.init parameters are very crucial to any database. Any change to this would have global implications. As we know, changing a database.init parameters could be risky and might need to bounce the database. ADDM Spotlight gives you reasons of why this issue is occurring. What are the possible ways to solve it? One of such is parameters change. As we saw in previous slide about events annotation, where I spoke of configuration changes, those changes might have come from the recommendations of this section. Top Activity Lite is introduced in 13.5 RU13. A DBA or L1 triag analyst or operator wants to monitor the performance of database in real time in an efficient or performant manner to view all the critical information required for diagnostics. Having the information in different places would make it annoying to keep moving around. For all those problems, we have Top Activity Lite as a solution. The performance diagnostics provide on a single page view that renders well and have a NOC-like use cases, where there is a single screen which captures all DB activities. This page is a perfect blend of Performance Hub and older Top Activity. I'm sure a lot of you folks are familiar with. Although we had a subset of Performance Hub, it comes with benefits like it provides a single screen with easy visualization of issues through compact UI. It provides the information of last hour effectively. Top Activity Lite is a simplified version of Performance Hub. It also retains previously selected settings in the browser. I'm going to talk about auto refresh, time viewport or time slider, Ash Analytics, and SQL monitoring tabs on Top Activity Lite page. You can access Top Activity Lite from Performance Hub under Performance menu. This also needs diagnostic pack. Top Activity Lite supports real-time analysis for the last hour only. It has refresh options such as 15 seconds, 30, and 60 seconds, and it's off by default. The gray slider display the top SQL and top session activity tables for selected period. Whereas the page is auto or manually refreshed, the top SQL and session details are updated accordingly. The selected viewport can be moved to focus on a specific period to facilitate detailed analysis. For NOC-like use cases, this comes handy as it keeps refreshing without any human interaction based on chosen options. Next, we have time viewport or time slider. You must have seen Performance Hub where there are two summary timelines. As we spoke, Top Activity Lite as a simplified version of Performance Hub. Here, we have integrated both the timelines into one. In average active session chart, the information of top sessions and top SQL statements can be viewed. It has fixed size of 5 minutes. By default, the viewport updates to latest 5 minutes of data. However, if moved, it will remain fixed in absolute terms as the chart updates to show the last hour of data. The top SQL statements and top sessions are updated to reflect the newly selected time period whenever the viewport is dragged to the left or the right. Viewport behavior can vary differently. Top Activity Lite page provides two tabs, Ash Analytics and SQL Monitoring. Ash Analytics allows you to analyze and resolve transient performance problems that can last for only a short period, such as why a particular job or session is not responding when the rest of the instance is performing as usual. It allows you to perform scoped and targeted analysis by various dimensions and their combinations, such as time, session, module, action, and SQL identifier. SQL Monitoring. This page gives you much more detailed understanding of SQL that ran during a period. Although functionalities of Performance Hub, SQL Monitoring is present, but this is with a fewer data calls. Real-time SQL Monitoring UI enhancements. Before we jump into UI enhancements of SQL Monitoring, if there is any query that is running more than 5 seconds or using resources extensively, this feature would come in handy as it automatically monitors long-running SQL. It also monitors parallel executions and if there is a monitor in the hints of the query. Offline viewing and navigation through active reports is also possible, which facilitates collaboration between DevOps persona and Oracle support. And it also supports different persona and gives tuning guidance. You can access all these features in Performance Hub in SQL Monitoring tab. After you get the active report, you can view this particular page. One can choose the columns by checking the boxes based on the preference. We can also choose the columns we want to view on this report. There is a navigation option. If there is a long explain plan, then this comes handy where you can go around to find parent node, left node, or right node. Potential issues in terms of how rows are flowing around are highlighted in red. Internally, there are two reasons for the red highlight. If the executions are greater than equal to 1000 and rows are greater than 10 times estimated and less than one of the 10 times estimated rows. Estimated rows is the column which gives an idea of estimated rows, whereas rows are the actual rows while executing the query. As we've seen, tabular view, this is another option that gives you pictorial idea of query execution. As you see, each node represents different things like tables, views. Triangle nodes represent merge and nested joins. You could also see active and inactive nodes. Gray color nodes are inactive ones. Thicker the line, higher the number of rows there. It also gives you an idea of rows advancing in a SQL at a glance. We have two more tabs, Optimizer Environment and Outline. Let's say there is a dynamic or runtime parameter, and this tab gives what value was taken into consideration while running the query, which would help in understanding how the query was executed and what are the values it took. Not just that, it also consolidates, keep a few of .init parameters too. Outline tab. Sometimes we want others to look into our execution plan. This tab helps you reproduce that plan. It's a text. If copy and pasted, you can reproduce execution plan. Thank you, folks. I hope you had a great time listening to this session. If you have any questions, please go ahead. Thank you so much for joining us today.